I'm Robin Higgins, and this is the fastest to slowest rate of diffusion. Okay, so let's just remind ourselves what diffusion is. Well, it's when we have something that it's in a container. At first, we'll enter our molecules over here, and they'll all be on one side. But after time, because of the random movement of molecules, and in this case, gas molecules, you'll find that we completely diffuse throughout the entire container. So we're looking at which types of molecules, and all gas really in this type of example, are going to be slow and which are going to be fast. Well, the rate of diffusion is completely dependent upon molar mass. In other words, how much each gas weighs. So it's just how you would expect. A big, heavy atom or gas molecule is going to be very slow, and a light and speedy molecule is going to be fast. It's going to diffuse faster, right? Because all we're talking about is the movement from one side to spread out. So the fastest person wins. So let's take a look at a few different types of gases. Up here, on the very top left, we have hydrogen. That's the lightest gas of all, right? So it's going to be H2. And if we look at the speed of hydrogen gas, it's going to be completely spread out. So this is percent molecules, and this is the speed. So you have a lot of different types of speed because it's very light, and some are going really, really fast. Now let's pick another gas like O2, oxygen gas. Now, oxygen gas speed is going to look like this. And so we can tell if this is a higher speed and this is a lower speed, on average, the oxygen atoms are going a lot slower than the hydrogen atoms. And this will just increase depending on molar mass. So oxygen gas is a molar mass of about 32 grams per mole. Hydrogen is about 2 grams per mole. So what if we pick something that's right in the middle? How about water? So water, H2O, is about 18 grams per mole. Now, this is going to look right in the middle of 32 and 2. So you're going to have some that are going fast and some that are going slow, but not as spread out as hydrogen, not as condensed as oxygen. And you can actually predict, based on these trends, how fast any of these gases are going to go. So nitrogen, a little bit slower than oxygen, helium, pretty fast, but slower than hydrogen, and so on. And so this is the rate of diffusion for all the gases. So yeah, basically in conclusion, if it's a smaller molar mass but weighs less, it will diffuse faster. I'm Robin Higgins, and this has been Slowest Diffusion Rate versus Fastest Diffusion Rate.